think I'm gonna be in next year?
Well, depends on if you graduate.
I think I'm gonna graduate, Mr. Townsend.
Is that somebody who's missed multiple classes?
Two. I missed 2 classes.
Oh, heads up that there's going to be no heat in any part of the building next week.
Why?
Because they're working on the heat and they have to like turn it off so they can try to fix it.
Oh, so when it's working, will this class be?
Hopefully.
Don't be I don't get that one.
Third derivative?
Yeah, don't be a third derivative.
What does that mean?
Do you know what third derivative measures? Jerk. It measures jerk.
Okay. I don't get that. I don't think we've done jerk yet.
We don't measure jerk in calculus, but I thought you might have done it in. Third derivative is called jerk.
We're still on second law. We're not doing that much.
Oh no, I didn't do 31.
Am I capable of turning 31 in on Monday for full credit?
Could I do that
Okay,
too, maybe?
Why would you?
Because I had PSAT and I was really tired, but I didn't want to do anything.
Okay. It was Monday night's homework, so it's Friday.
Please.
Faye, you saw
No,
Tyler's
I can't do that.
What?
Tyler's dropping the 28th
The 28 what?
of this month.
Oh, seriously?
Yeah. I swear, I'm some kind of prophet. Yes. Okay, I listen to every Kendrick album before the disc, before all, like a week before all the discs came out, and I've listened to like 3 Tyler albums in like the past like 2 weeks. And now he's dropping an actual album for the first time in 2 years. I don't know what's going on.
Alright, if y'all did not turn in assignment 31, here's your last chance for full credit. I need it with your name on it in the basket, please. A couple of you already gave it to me, so...
I gotta be honest, this is probably like one of the easiest maths to take if you take everything beforehand.
Well, I still get deducted 5 points if I turn it in incomplete or late, but complete.
Are you talking to me? Yes.
But I get more.
If I bend the late policy for one person, then I don't have a late policy, because then I have to do it for
Wait,
everybody.
so would it be better if I finish it and turn it in late? Or turn it in
You should give me what you have, take half credit, and then when you finish it, you get half your points back. So in the end, you get 75% that way instead of 50%.
That's good enough.
Mr. Townsend. Guess who I saw yesterday?
Harper.
Christian.
Oh. And?
I mentioned you.
Yeah.
I just thought it was funny. You literally talked about him Wednesday.
Did you tell him I talked about him?
Yes,
And how?
Oh yeah, me.
but just that one time.
Okay.
When is the quiz?
What did he say?
Yeah, he was excited. He said he misses you.
Oh.
So,
Well, he doesn't miss the work.
Next Wednesday?
yeah.
Next Wednesday.
Okay. Let's get started, please. All right, the handouts you guys picked up, this is the third BC topic since we've had a quiz. So this will be our last BC topic before we review and take another quiz. This will round out the rest of our vector work. So 2 classes ago, we talked about how to take the derivative of a vector, which was pretty straightforward. Last class, except for Wednesday, and Wednesday in addition, I guess, we talked about integrating vectors. And then today, with assignment 32, we are going to look at motion with vectors. So most of this is going to be consistent with other stuff you've talked about. If you've got a position vector, you can take the derivative of both parts, and you've got the velocity vector. When you take the derivative of both parts of velocity, you have acceleration. So this relationship between position, velocity, and acceleration is consistent with what you already know. The one that I think is not as intuitive is speed, which we write this way. Also, this is known as magnitude. you have to know those two absolute value symbols. They're not really absolute values, but they look like double absolute value signs. Means magnitude. And the way we're going to do that is, I would show you how to derive it if I knew it, but I know it's close to Pythagorean theorem. It's like you're taking the square root of something squared plus something squared, and the somethings would be x prime and y prime. So if you have the velocity vector, which a lot of these questions do, you already know x prime and you already know y prime. It's just a matter of plugging it into the formula. But again, I know that comes from Pythagorean theorem, but I haven't actually derived it myself, so I can't show you where that comes from. Okay, so first question, or first example here, asks us to do a whole bunch of stuff. It gives us a position vector, and it asks for a velocity vector. So what do we have to do to a position vector to make it a velocity vector? Okay, so the derivative of sine something would be cosine of something. Chain rule would multiply by a fifth. 5 times a fifth just becomes 1. The derivative of cosine something is negative sine of something. Chain rule would multiply by 1/5, and then 5 times 1/5 just becomes 1, so that's why the 5s are disappearing. And that's it for the first part of the question. There is the velocity vector. It is that straightforward. I got this one. Okay. If we wanted to know the speed of this as time goes on, then we would need this formula. So speed is equal to the square root of x prime squared. So we actually have that right here. Cosine of t over 5 squared plus y prime squared, and y prime is the y component of the velocity vector, so I don't have to do the work a second time. I guess it goes without saying though that if you're going to reuse this stuff for multiple questions, you need to be extra careful that you did chain rule and that kind of stuff. Okay, so right here I've got cosine of t over 5 squared plus negative sine t over 5 squared. This simplifies pretty nicely. What do you think all that comes out to be? It is 1. How come? How do you, those of you that see that that's 1, how do you know it's 1?
Oh, sine squared.
Right. Sine squared of an angle plus cosine squared of the same angle always equals 1. That's the first Pythagorean identity. You're just not used to, usually you see it as x, not t over 5, but it's the same thing. If it's sine squared of some angle plus cosine squared of the same angle, that becomes 1. And of course, the square root of 1 is 1. So the speed would be 1. And it looks like they want the acceleration vector. But just like taking the derivative of velocity gives you acceleration and everything else calculus, same with vectors. Take the derivative, make sure you do chain rule, and take the derivative, once again chain rule. So to me, going from position to velocity to acceleration, I need this at the start of class. And you don't have your name on it. So to me, this is pretty intuitive. This is how I would guess to do it if no one had ever told me. But speed, this formula, of course, not as intuitive. So that's probably the thing you need to pick up. Okay, we recently talked about this a couple weeks ago, but this comes up in a few questions. For a particle to be speeding up, the velocity and acceleration, what'd you say? Right. So like they both need to be Virgos. And to slow down, opposite sides. One needs to be positive and one needs to be negative. Okay, so once again, I don't know why they're asking this in question 2 when we already did this in question 1, but here's a position vector. It wants velocity. So derivative, comma, derivative. You're done. And then it wants acceleration. And if you've already got velocity, then derivative, derivative. Okay, for part 3, it says find the speed at t equals 2. If this is our position velocity, or position vector. So, without looking up at the top of the page here, I think it's pretty easy to remember it's the square root of something squared plus something squared. But what was the thing here without looking at the top of your page? Okay, it's x prime 3t. No, this is just x. If you're looking at velocity, then that is x prime. And that is x prime. Or y prime. And then it says that t equals 2. So if you plug in 2 here and here, you can throw that in your calculator. And I don't know. I don't remember what the number is because I don't have my sheet in front of me. But I want to go ahead and make sure that we put in the right value though. Okay, this came out to be 3.000089. But you would need a calculator for that. 3.00089. Okay, the one other thing that's going to come up, another formula, is if you would like to know the total distance traveled by a particle. Basically what you're doing is you are integrating from a to b. A to b is going to be for the x, beginning x to ending x value. And then what does this stuff mean? Okay, magnitude and speed. They mean this, they're both the same here. So I think it makes sense to write speed. And let's go ahead and plug in the formula that we have for speed up above. Square root, integrating from a to b, the square root of x prime squared plus y prime squared, in terms of t, of course. Now, I don't know about Miss Cross, but for us, for those of you that had me for AB, I really tried to emphasize when you saw total distance traveled, what should jump out at you about this? Good, absolute value. Why does this formula not tell us to worry about absolute value? Right, and these are both squared. So even if this was negative, as soon as you square it, it's positive. Even if this is negative, when you square it, it's positive. A positive plus a positive is positive, and the square root of a positive is positive. So everything is already being positive. That's why you don't have to have the absolute values. If you really want to put in the absolute values, you can. It's not going to change anything, though. So, okay, so on the next page, I think we got 2 more examples. If we tell you this is the vector, and we tell you where the position is at time t equals 0, you should be able to find the position at t equals 3 and how far total did he travel during that time. So how do I go from velocity vector to a position vector? Okay, so let's integrate. Position will be integrating this. So t squared plus t and 5t. You're happy with that? Good. You're not supposed to be happy with that. Plus a C here and plus a C here. Probably not the same number, so we probably shouldn't call them C. We should call it 1C1 and 1C2. Now, on Monday, I plan on passing back your third quiz to you when we do some review. But I would say, I think it's pretty close, if not the most missed thing you guys on last quiz. There was like one integration question, and even those of you that did the partial fractions great, a lot of you forgot to put the plus C at the end. So
Was it me?
I think I.
Was it me or sure?
I'm just saying, like, I know you know it, but you got to develop a habit there. Okay, so now when time is 0, it's supposed to be at 1, 2. So if I plug in 0 for t, it's supposed to equal 1. So C1 must be 1. So I'm going to change it to 1. And when t equals 0, y is supposed to be at 2. So if I plug in 0 for t over here, that's supposed to equal 2. So C2 must be 2. And now we've got the full position vector, which I do S of t, which stands for like space, like where you are in space, which is position. It might be smarter to call it R of t, just because that's what they tend to do. But as long as you don't get it mixed up with velocity or acceleration, it should be fine. Okay, and then 2, what is the total distance traveled on this interval? So, total distance traveled. Okay, so we would need to integrate from what to what? Okay, and then follow the formula. Square root of x prime, which is not that. Right, it's up here. Almost made that mistake. X prime, which is what you have in the velocity vector, plus y prime squared. And because of that square root, I don't think you can do that by hand. You would need a calculator. And if we threw this in the calculator, it comes out to be about 19.694. Or 649, sorry. Okay, and then you can see they're going to take this, if you know about the position vector, and you can find the velocity vector, and you can find the acceleration vector, they can start to tie in some of the other calculus stuff that you also know about those things. So, for example, question 5, particle moves along a curve so that this is his velocity vector. When is it moving to the right? So when does something move? Forget this question. And calculus, how do you know if something's going to the right? Okay. Do I care about this whole thing being positive?
Why would it just be V?
It's just this part.
Oh.
The horizontal component determines its left and right movement. The vertical component calculates its up and down movement. So if I care where it's going to the right, I need to make sure that this, which is x prime, is bigger than 0. Positive derivative means you're going to the right. And these are kind of funny to solve, but you could divide both sides by 2. And for this, t would need to be what do you mean?
I don't know. Wait, never mind.
Well, if t is 0, what does all this go to?
1.
Okay, the whole thing goes to 1, right? Is 1 bigger than 0?
Yeah.
Okay, so 0 is supposed to be part of our answer.
Greater than 0?
Should I know it can
Greater
include.
than or equal to?
Well, what about negative
Wait, no,
numbers?
No, never mind.
It can be positive.
Wait, no, yeah,
it's
it's-
positive with negative. It can be any number.
It can be
put in
any
there.
number.
No, it can't be any number.
No, because like, if t is negative or positive, it'll still be positive.
Yeah, you can get it.
T can't be any number.
Why not?
Why don't you put that, put that into the best case, put the negative. Well, yes.
Oh.
Time being negative doesn't make sense. They put it in the directions. So algebraically, yes, what you're saying is correct. But we're only moving forward with time, so time needs to be a positive. Ben, you need to get up. Okay. Okay, and then for what values of t is the particle moving up? So it's kind of the same thing. The y component is going to tell you how far up or down it's going. Y prime represents the rate of it going up or down. So if y prime is positive, it's moving up. So you really are trying to figure this up. And what value makes this equal to 0? Okay, so t cannot equal 4 because then you would have 0 is greater than 0, which doesn't make sense. So t can't be 4, but it could be anything bigger than 4. Because if it's 5, you get 1 over, well, whatever. If this is positive, this is guaranteed to be positive because you're adding 5 and this one's subtracting 4. So for this to be positive, you need them both to be positive or both to be negative. And this is never going to be negative unless you're talking about negative time values. But once again, we're assuming positive time. So that's when the y prime is greater than 0. Okay, so this is obviously what it's slowly building up to. The first few questions are much more straightforward. So as we have been doing, if you guys would go ahead and start on question 1 and 2. I will share the answer to 1 in a minute, go over it for those of you that need help with it. Do the same thing for 2, 3, 4, and then at that point, I'll just help out where you get stuck. Kind of need to all make sure we're got a good start, because if you're struggling with the first couple, it's going to just carry over to the others too. So. Well, everybody's here today. I shared my answer to question 1, so if you got that right, keep going, and if you don't get that right, I'll go over in a minute.
Man, my head hurts.
You better hurry up and finish then, before you get a migraine.
I think I'm just dehydrated. I'm gonna go fill up my water.
Okay, if you did not end up with an 8-2 on question 1, they give you x of t and y of t. So they're really giving you could pair those two up with a vector, but that would just be the position. Velocity is going to be derivative, comma, derivative, and it wanted velocity at time 1. So there was nothing to plug in for the 2. It just stayed a 2. But you could plug a 1 into 8t and get 8. And so that's where I got that as an answer. Everybody okay with that? Okay, let me give you another minute. There's my answer to number 2. So same thing. If you're good with that, start moving on at your own pace. This you with no name on it?
You can tell.
Well, I'm hoping it's the only one not finished.
Oh. Is this thing due today?
This is the only class time I'm giving you to give it.
32?
Today's?
Oh.
Yeah. It's like 17 questions total, and we just, well, I don't even know if it's got 17 total.
It's got 6 pages.
Okay, how many questions is it?
16.
16, okay. Are you done with question 1 and 2?
Yeah.
So you got 14 left in like an hour. Yeah. About number 5? Okay, let me work question 2 real fast, and then I'll jump to that. Okay, so just like question 1, question 2 gives you x of t and y of t. If you want to pair those up, you need to realize that is just position. You need x prime comma y prime for velocity, and you've got to take the derivative a second time and just make sure you remember chain rule. First time you take the derivative, it creates a negative in the horizontal component, and then the second time it switches it back to being positive. And this one wants a of 1. So if you plug in 1 into this and 1 into this, e to the first is just e, and e to the negative 1 is 1 over e. Everybody still okay with number 2? Okay. Okay, I'm going to share the next 2 answers. It looks like number 3 should be left and up, and then negative 2 4e to the 4th. But we also had a question about number 5. So I'm going to look at number 5, see how that goes. Okay, so question 5 gives us a position vector.
No, question 5 like from the beginning. With that part A and B.
The part that had A and B.
Yeah, go up.
Oh, okay. My bad.
It says x prime is greater than 0, and you just plugged in the x that was given to us. Why?
Well, this was velocity. Velocity is made up of x prime, y prime. If it was position, it would be x and y. Sorry, I didn't mean to make you wait. I thought you needed to see further down. Okay, so give everybody a few minutes, and I'll go over 3 and 4, and then plus whatever else y'all need help with. But we'll assume that everybody's got a good starting point after question 4.
Yeah, just one over there.
I'm sorry.
You okay?
Yeah, I'm fine.
Yeah.
I feel bad because it, well, like it was almost intentional, but it wasn't. Okay, so on this, I already had a grade for you in grade book, so I think I might have accidentally given you credit for this one when you turned in number 30. So you need to see if you have number 30. Because number 30, I have a 0 for you. So I think I might have just put it in the wrong spot. Got stuck with me as a teacher again. 2 years in a row. Oh. Yeah. I don't know. If you want total distance travel, you got to do that. And you integrate that from A to B. Okay, does anybody need more time to finish trying question 3? Okay, so question 3 gave you the position vector. And that is the velocity vector. And the fact that the horizontal component is negative is how I know it's going to the left. And when it's passing through 4, 4, when this is a 4, t has to be t has to be 1. And when t is 1, this is positive. And when the vertical component is positive, it's going up. The vertical component's negative, it's going down. Okay, is that enough for everybody that did not get number 3? Okay. Number 4 is even easier than number 3. But I shared my work up there. I will take it off in just a minute. Obviously, I'd like you to check your other answers also. But those are on the website. So once you get past question 4 and you feel okay with that, then use the website to start checking the rest as you go along. And then, of course, I need y'all to speak up and tell me if you're not understanding why something is the way it is. So again, on Monday, I'll remind you of the stuff that will be on your next quiz. And I won't be able to do this all year long, but some of your quiz or all of your quiz questions will come from the practice that you've been doing. So if you don't know how to do question 5 on here and you don't ask for help, there's a chance it's going to end up on the quiz, and then you're not going to know how to do it on the quiz. So you need to move forward with that. Okay, and then as you guys finish, if you'd come bring it to the basket so I can put the grade in. And you have almost 60 minutes left, so that should be pretty easy to finish up, I would hope. But let me put in a couple of these grades real fast, and then I'll come around and help. Guess I should find my work bill first.
This is it was this.
You're already on question 12.
I don't have like enough stamina to keep going. Like I already want to fall asleep right now.
Stand up, stretch your legs for a second.
I don't know if this is right or not.
Well, good thing I give you a way to check your answer.
Yeah, but
Which question is it?
it's 12.
12. Oh, I don't have that one finished.
Is it on your math page?
It is.
Okay. Oh, I have to log into my computer.
This one is tricky.
It said it was tricky, but like, I felt like it was tripping me up because I did it really fast and I thought I did something wrong. So I don't really know if I did it right or not. Wait. Wait, no. Actually, I don't know. That was 0? Oh.
Are you okay after question 12?
Yeah,
Okay.
but I still need to check my answers.
I'm not, I don't know, I have 30, but it's not like marked.
Put your name on it and put it in the basket. Yeah, new headings? It's very school spirited. Sorry. Okay, you need help yet?
No, I haven't done stuff yet.
Does anybody need me to come over and try to help yet?
Did you actually take physics from Mr. Reed? You did? You said he remembers you. Wait.
Of course he remembers.
Well, that's true, but like, I don't know. I just found it
I'm
funny.
his favorite teacher at the school.
Really?
He always tells people I'm his favorite math teacher.
You are too, to me.
That's good, because I'm your only math teacher.
Well, ever, you know? You'd be even more of my favorite teacher if you gave me full points on this.
But why do you use that respect? Maybe, but then you wouldn't respect me, so.
No, I respect you a lot, Mr. Johnson.
No, that doesn't sound. That sounds like you want me to question my morals.
It's already the difference.
Morals?
Yeah, it's already
Is your Lakeville policy an attribute of your moral compass?
It is.
What do you use?
Is it not for you?
Not really. I don't have a late mode policy. Cause I turn everything
Oh, you
late.
just use a Wi-Fi.
So you just plug it in?
Oh, wait, you just did a C1.
The answers aren't on there. Wait, I'm on AP. Never mind.
Do you do cosine?
You use it every
Sometimes you need to refresh the page too if you have it left open.
Okay. Why do I always have to download a new file every time I look at answers? Could you not just like put it in a file?
I probably could, but I don't like to do that. Some people don't have internet at home, and I want it to be downloaded so they can still access it.
Oh, that's valid. But now I have like 15 files dedicated to calculus.
Okay, go delete them all. You don't need
That's like
them.
a lot of work though.
No, it's not. I have to do that stuff all the time. It takes 5 seconds if you just go do it.
Oh, I got it right.
You should still maybe put it start by it if you don't feel confident.
What do we use your calculator? Oh. Wait, you can do that, right? Oh, yeah, it does, but I forgot that you could just put it in.
I think I saw this and put the grading for that.
Oh, yeah, we are integrating.
I don't want to come to the red line.
In the position that there's some.
Wait, did you get T squared plus 3T?
C1 is 1, what did you choose? And C1 is 1, and C2 is 5. So it has position.
Great shit, bad.
Yeah, because it's just 0 very bad.